what we learned yesterday. So I'll give you a moment to try to answer the following. So try to figure out the domain and the range, tell if it's a function, and then the same for number 2. And I did post the blank notes on Canvas. If you are able to print that, it will be helpful, but it's okay if you can't print it, I understand. That's one of the reasons why I make the video in the first place. So I'll give you guys about 3 or 4 minutes, and then we'll go over this. This is definitely going to help you with this part of our content. For our domain, we just take our x values, which is what this person did, and then that would be our domain. And then for our range, we just take our y coordinates, and it's okay for our y coordinates to repeat, but it's not okay for our x coordinates to repeat, especially if they repeat and they're going with a different number. So that is correct. So my domain is 1, 2, 0, -1, 4. And then my range is just the set of -1, -3, 5, 3, -5, and -4. And it is definitely not a function because the -1 right here is repeating, and also the 4 is repeating as well. So those are definitely not, that's not a function. Okay, so let's talk about number 2, which number 2 is definitely more difficult because it is a continuous curve there, and so we have to account for that, and that's when we use that interval notation. So for my domain, I want to go from left to right. So the farthest left value is -2. And then when I go to the right, I would say maybe it's 16, except for there's an arrow there. That arrow doesn't just go up, it's going up and out. So eventually, infinity would intercept with that arrow. That arrow would be getting closer and closer to infinity. So this would be infinity. For infinity, we always use a parentheses. We never get to use a bracket for infinity. And then for my range, we're doing bottom to top. My lowest value is 1. And my highest value, you would maybe think it's 4, but we can't forget about the fact that there's this arrow here, right? And so the arrow is going all the way up forever. So eventually, it would intercept with infinity. And this one is a function. It does pass the vertical line test. Are there any questions on the warm-up? Okay, now remember, you can always stay on and ask questions as well if needed. I usually try to end a little early for that reason. Okay, so that's a great question. The reason why it is a bracket is because -2 is included, and anytime it's an ordered pair, we would want to put a bracket. But if it looked like this, and we haven't really had any that look like this in the first place, but if the same graph had an open circle, that's whenever I would put a parentheses with my number. Yeah, that's a great question. I'm sure other people had the same question. And then what's really tricky is when we do intervals of increasing and decreasing, we always use parentheses. So that also makes it a little bit tricky. Any other questions? All right, let's get started. We're going to go ahead and move on to, I wish that would get off the screen. That's bothering me. Okay. Oh, well, this is kind of funny. So I did a MyLabs, we had a MyLabs syllabus quiz really just to check your lockdown browser, and I thought it was so funny because it says, although I dream that I was a teacher at Hogwarts is actually not the right answer. So if you missed this, I gave you your point back because I thought that was really funny. But it says the course is called, and make sure you choose college algebra, everybody. please don't choose Hogwarts. So that is just a 1-question syllabus quiz to make sure that you have that lockdown browser for when you take your test. Okay, I had to share that because I thought that was too funny. Okay, so we are going to go ahead and move into, I want this off my screen, graphing linear functions, which we do have a little bit of a prereq that we're going to talk about with our ordered pairs. And we're going to try our best to cover graphing linear functions and graphing quadratic functions. And so we're going to try to get through both of these this evening. If we aren't able to finish, then we'll just have time tomorrow. It'll be okay. But we're going to start with the prereq of ordered pairs. And so I just want to remind you that when we have our ordered pairs, we have the coordinates x, comma, y, and x tells us if it's negative, it tells us to go to the left, and if it's positive, it tells us to go to the right. And then y, if it's negative, is telling us to go down, and if it's positive, it's telling us to go up. And so really, the ordered pairs, it's almost like an address. And in this case, for my soccer ball, I have it located 3 to the right. So the soccer ball is at the ordered pair 3, comma, and then I'm up 4. So since it's 3 to the right, it's a positive 3, and since I went up, it's a positive 4. So 3, comma, 4 is my ordered pair. Now I'm going to color code this, and I'm going to ask you to try to find the other ordered pairs that I'm placing on this graph. So I don't have an infinite amount of soccer balls. That would have been more fun, but that's okay. I'm just going to put these in a few places, and I want you to try to think about what those ordered pairs would be. Let's do, how about a purple? Purple's fun. Okay, so I'll give you a moment to try to locate those ordered pairs, maybe sketch them on your paper, and then if you want to type them into the chat, you can. You can just put like the color and what the ordered pair is. And feel free to, you can type it to everybody because that might actually help people. So I'll give you a moment to do that. Okay, I'm going to go ahead and reveal the ordered pairs to help you, but I can see that several of you have already typed it into the chat. So thank you for helping in the chat. I know that helps others as well. Okay, so I'm going to go ahead and start with green. The order that you went in does not matter. Green is at the origin, so I don't go left or right, so that would just be the ordered pair 0, 0. And then for red, I went to the left 3. So I always go left or right first. So since I went to the left 3, that would be a negative 3. And then since I go up 3, that would be a positive 3. And then for purple, I go to the left. So you always, when I say go right or left, I'm talking about like you always start at the origin. I probably should have said that. You always start at the origin. So I go to the left 3 to get to purple, which would make that a negative 3. But I don't get to go up or down because it's just right there on the axis itself. So that's going to be negative 3, 0. And then for yellow, it's a similar idea. I go to the right 5 and I don't get to go up or down. So that would be 5, 0. And then last but not least, I have blue. And for blue, I would have to travel to the left 5, so that would imply a negative, and then down 2 would also imply a negative. Are there any questions on the ordered pairs? And I'm going to show you on my labs how when you do the linear functions, you actually have to like click on the ordered pair for it to accept it. And so it's really important that we know our ordered pairs. Okay, we're going to move on to graphing linear functions. We've accomplished the prereq. So now we're going to talk about really what is a linear function and then some important attributes to that. Okay, so the definition of a linear function is a function of degree 0 or 1 whose graph is a straight line. Now, when we say degree, I'm going to show you what that's talking about, like what that's referring to. So degree of 0 or 1, so let me put some examples here for you, would be like y equals, oh no, somebody got kicked out. Don't worry, I always let you back in. It sometimes happens, and that's okay. Okay, so y equals 2/3 x and then minus 5, or y equals 5x minus 2, or y equals 7x, negative 7x, or y equals 2. Okay, so the reason why these are degree 1 or 0, it's all about the exponent on our variable. And our variable is x. So I know it's invisible because a long time ago people got really lazy and they stopped drawing ones everywhere. But there is an invisible 1 right there. And so that means the degree is 1. And in this y equals 2, it's actually really difficult to see because it's invisible. But there's also an x. I'm going to draw this in invisible ink, kind of. There's an x to the 0 power. Okay, I better just actually draw it like real, for real. So x to the 0 power, because there is no x. It could be thought of as a degree of 0. So that's what it means for our linear functions. We have a degree of 1. Typically, our domain and range, unless it is special, which really I would say that these are special, when we just have y equals a number. So these kind of are like a special category of a linear function. Typically, our linear functions will have a domain of negative infinity to positive infinity and a range of negative infinity to positive infinity. And the reason why that typically happens is because if you think about what that graph would look like, so I'm just going to sketch what a linear function would look like. It's going to go all the way to the left, it's going to go all the way to the right, it's going to go all the way down, it's going to go all the way up. And so typically our domain will be the set of all real numbers. But for our class, we use interval notation. So that would be the negative infinity to the positive infinity. And the good thing is we already started to talk about domain and range. So that's definitely going to help us. Now we're going to talk on the next slide. We're actually going to talk about this special function down here because it has a special name. So give me a thumbs up when it's okay for me to click. I kind of need to see where you guys are at. Okay, so I only see like a few thumbs up. Okay, I see more. Okay, looks like we're good. Now I am going to start posting the videos at night because I think that actually helps you. So I apologize if I go too fast, but I know we've got a lot to cover in this 5-week course that you guys signed up for. Okay, so let's go ahead and move into that special function. That is called a constant function. So a constant function is a linear, so it is a linear function, but it's special because it's constant. It's a linear function in the form y equals b, where b is a y-intercept. Do you have a question? I hear somebody is unmuted. Michael, do you have a question? Oh, yeah, it's okay. I was just making sure, but anytime you guys want to interject, you can, especially if I make a mistake. Please, tell me if I make a mistake, because sometimes that happens. Okay, so what does that look like? Let me show you an example. If we have y equals 2 or y equals -1, or y equals 1/2, or y equals 0. All of these are called constant functions. And the reason why they're constant is because the only output value is the value itself. And it's a y-intercept because the whole time the y value is 2. So if I was going to graph y equals 2, it would look like this. And so it'd just be a horizontal line. So constant functions are really easy to graph. They are just a horizontal line at wherever that value is. So in this case, that would be y equals 2. And if I was trying to graph y equals -1, I'll do this in red, that would just be down here, and that would be y equals -1. But you can see that we're not going to have the same domain and range that we had for our linear functions that are not special. What do you think would be affected depending on the domain and range? Like, which one would be affected? Or different, I should say. Well, actually, that's not a bad try, but the domain is going from left to right. So from left to right, I do have, like if I scan from left to right, like my arrow will touch, right? And it'll go, this like whole graph is part of my domain. But when I try to do the range, which goes from bottom to top, my range is very limited, right? My range will only be wherever that value is at. So my domain will be -infinity to infinity. But my range, this is really cool, the range is just whatever number it is. So for y equals b, the range would just be b. And in the case of y equals 2, my range would be 2. For y equals -1, my range would be -1, and so on. So the range is very limited, whereas the domain would still be -infinity to infinity. So if you think about it, we have a linear function that looks like this, right? And then we have one that looks like this. Show me with your arm or your finger, what do you think the last one is going to be? Good, and thank you for not showing me your middle finger. I probably shouldn't have even said your finger. That would have been really bad. Only my high school kids, right? Like, no way the college kids are going to do that. Okay, so you guys are right. That would be a vertical line, and that's the one we're going to talk about next. Now, is it okay? Do I get a thumbs up? Can I move? Are we good? We okay? Okay. All right, so then it's the vertical line, and I put it's kind of sad. It's kind of sad if you're a vertical line because, well, I don't want to give it away, but it's kind of sad. Okay, so let me explain. A vertical line is when we have the form x equals a number. So a horizontal line looks like this, and it's y equals. A vertical line will be x equals, and it can be whatever number, as long as, of course, it's a real number. So I could have like x equals 5, and if I had x equals 5, then that would just be a vertical line at 5 on the crossing through the x-axis. So this would be the line x equals 5. If it was x equals -10, then that line would be like way over here, and it would look like this. Now, as far as our domain and range, which one do you think it would affect? This time, as a few of you typed it into the chat to me, this time the domain would be affected, right? Because if you think about it, the domain is from left to right. So as I'm trying to find my graph, from left to right, there's like nothing over here. None of this is part of my graph until I get, in this case, to -10. And then if I keep going, none of that is part of my graph either. So my domain is only whatever that value is here, right? So if it's a -10, then -10 would be my only x value. If it was x equals 5, then 5 would be my only x value. However, for my range, which is from bottom to top, my range starts way down here at -infinity. And it goes way up, right? All of this would be part of my graph all the way up to +infinity. So my range is still -infinity to +infinity. But my domain is extremely restricted. Now, the reason why I say it's sad is because if it's a vertical line, it does not pass the vertical line test. In fact, that's like extremely flawed, right? Because the poor thing is like a vertical line itself. So the vertical lines are not functions. So this is not a function. And that's why it's kind of sad. It's not even considered a function. But you still see it. Like, you'll still need to know what the graph looks like. All right, so the next thing we're going to do is I'm going to show you how to graph these really kind of like by hand, but also in MyLabs. MyLabs has a really specific way that they want you to graph it. It's a little ridiculous, I'm not going to lie, but I've learned the hard way that if I don't show students how to do it, then they struggle with it. And so I did make a video of how to do it, but I'm also going to show you what it looks like. I'm going to try to if it'll let me share the screen. Sometimes MyLab doesn't let me do that. Okay, let's go into graphing linear functions. No, we've already done that. Okay, so we're going to do this first example, which is f of x equals x plus 3. So we've put in a lot of the definitions. We've done a little bit of prereq skills. That's going to make this like really easy. And to graph it, we're actually going to create a table. So a table is like the old-fashioned best way to quickly graph by hand any functions. Any functions in your future math classes can be graphed by using a table, which is really a good thing. So we're going to create a table. And I like to make kind of like a fun big table. So we're going to have x, and then we're going to have my work, which will be the function f of x is equal to x plus 3. Now remember, f of x is just fancy for y, the y equals, right? So it's just our y coordinate. And so I'm going to put a y here because that would be the output. And then last, I would want to do my ordered pair. Now MyLabs makes you do at least 2, which makes sense because if you have 2 ordered pairs, surely you just connect them, draw a line, and that would be your equation. Like that would be your graph. So it only makes you do 2, but we're going to do like a little bit more, not too crazy, but we're going to do a few more than that. What's fun about this is you get to pick your x values, and you can pick whatever x values you want. But some choices are better than others. Just like in the real world, sometimes you can make a choice that is like super efficient, or sometimes you can make a bad choice and maybe it causes a little bit of strife or something. So we want to pick like fun, nice choices for x. For example, I probably will always pick 0. Why do I pick 0? Because 0 is easy to plug in. It is just really nice when I pick 0. Besides, it will give me the y-intercept, which is cool, okay? So I'm going to plug in 0. And all I have to do is I'm going to find f at 0 by plugging 0 in for x. So that would be 0 plus 3, which is 3. So that's my y value. And my ordered pair is just 0, 3. So I'm getting my ordered pair essentially from those 2 values. The number I pick, and then I plug it in, and I get that dependent variable, which is y. Some people don't need that middle column. They don't really have to show work because they kind of like do it in their head. But I like to show all of my steps for you guys. Okay. Now, let's pick another value. Show me with your hands what value do you want me to do next, because it's your choice. Okay, I see a 1. Thank you. 1 is a great answer. 2 is a great answer. Okay, so let's do 1 and 2, which is actually what I had on my paper, so that's great. Okay, so f at 1, that's just function notation. I'm just going to plug 1 in for x. So I get 1 plus 3, which is 4. So my ordered pair is 1, 4. Now you can probably predict what's going to happen whenever I plug in a 2, but in the future we're going to be doing advanced functions, and those predictions are not as obvious. So I will go ahead and plug it in and show what that looks like, but I bet you have realized that that increment would be a 5, right? Okay, now I'm going to plot this and I'm going to connect the ordered pairs. So I have 0, 3, which is of course not left or right, right? I start at the origin and I didn't get to go left or right because it was a 0. So I go up to 3. And then I have 1, 4, so that's to the right 1 and up 4. And then 2, 5. And so I can see here that my slope is up 1 to the right 1, up 1 to the right 1, or down 1 to the right 1. And so I could even use that to go a little crazy and just put a whole bunch of ordered pairs on there. But MyLabs doesn't really make you do that. You can just go ahead and connect them and include arrows. Now what I'm going to do is I'm going to pause the video to show you what this looks like on MyLabs, because I've learned in the past that that can really kind of like upset people. And so I want to show you what that looks like. And I'm going to actually share that video that I've already made. Okay, so hold on a second. And I'll go back to the screen in just a minute. Okay, hold on. Ugh, okay, I am going to play this just briefly to show you what it looks like so you know. I hope you can hear the volume on this. I'm gonna unplug this for a second. So you guys will have to tell me if you can hear the volume or not.
This video is going to help you with the homework.
Uh-oh.
And
hold on. You can't see it, can you? Can you guys see it? Okay, hold on. Let me share it. Not bad. Oh, that's funny. Okay, so let me go here. Share. Okay, here we go. There we go. Okay, so I want to show you what it looks like, and I'm going to try to be quiet, and I'm not going to listen to myself because it's going to drive me crazy.
I know we've already gone over. So we already made our table, and one of our ordered pairs was 0, 3. So I just go down to the line tool, which is right here next to the arrow, and I click on the line tool, and then I find an ordered pair on our table. So we have the ordered pair of 0, 3. So I just click on 0, 3, and then you can see it creates a line. And then I pick one of my other ordered pairs that we created, which was 1, 4. So 1, 4, I will go to the right 1 and up 4. And you can see that I've selected that ordered pair because it's showing up. And so I click again, and that creates the line. So it only makes you use 2 points to create the line, even though we came up with 3 on our table. There isn't an infinite amount of points. It does.
Ugh, gross. I hate listening to myself. Okay, but that is how you do it on MyLabs, and you can reference that video when you need to. That video is just right here. There's actually 2 videos, but this is one that shows you how to do it in MyLabs, because I know it's so frustrating if you don't know how to do it in MyLabs, but you understand the concept. So that will help you with MyLabs. Okay, so let me go back to my iPad. So this will just take a second. Let's see. Okay. So you do have to click on that line tool, and then you have to pick 2 points. So the first one will start, and you have to go to that other ordered pair that will help you. All right. Oh, that's weird. It kept playing. Interesting. Let's keep going. So we're going to do more that are a little more challenging. For example, we're going to have one with a fraction. So we're going to try this one. Now this one is a little more advanced because we have a fraction, and you know, I actually forgot to do the domain and range on the other problem, but for all of these, as long as it's not y equals just a number, the domain and range is going to be negative infinity to positive infinity. The range is the same. As long as it's not y equals like 5. Of course, that would affect our domain and range. But as long as you've got an x here and that degree is a 1, then that will be your domain and range. Okay, so let's go ahead and make a table. So we're going to have x, we're going to have my work, which is f of x is equal to 1/2 x plus 6. And then we're going to have the y, and then we're going to have our ordered pair. Now, we're going to be very efficient. So we're just going to do 2 this time. But you can do as many as you want, especially if you think it's fun. You could do like 100 if you wanted to. Okay, so let's pick 0, of course, right? 0 is always a great choice. So f at 0 so I would do 1/2 times 0 plus 6, which is just 6. So my ordered pair would be 0, 6. Now, here's the deal. If I choose 1, which is not necessarily a bad choice, but if I choose 1, I do want to show you what happens and why I personally would not pick 1. So let's say I pick 1 and I plug 1 in. When I do 1/2 times 1, I get 1/2. And then when I add that to 6, I get 6.5 or 6.5. Well, the problem with that is it's going to be hard for me to graph it, right? Because I'm going to have to go in an increment of 0.5. So even though that is an ordered pair on my graph, I wouldn't necessarily choose it because the result is a decimal or a fraction. Okay, so I wouldn't pick 1. But show me with your hand what would be something that I could pick that would work out. 2, thank you. Okay, great. 2 will work. And the trick is if you look at the denominator here and you just multiply it by like a factor of that, then you should be fine. Like I could pick 4, I could pick 2, I could put 6, I could put -6, as long as that's divisible by 2. So 2 will definitely be a good choice. So I'm going to do f at 2. So 1/2 times 2 plus 6. And then 1/2 times 2 is just 1. And then 1 plus 6 is 7. So 2, 7 will definitely work. So I'm going to go to 0, 6, and I'm going to place my ordered pair there. And then I'm going to go to 2, 7. And then from here, if I want to go a little crazy, I can use the fact that my slope is up 1 to the right 2, and then I could also continue on up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. But I'm telling you, especially like this is the year 2022, you don't have to go that crazy. Technology will do that for you. So when you have 2 ordered pairs, you can quickly plot that graph for the line. All right, we are going to, ooh, yay, this is fun. We're going to do a special one, and then we are going to do one that's a little more advanced. Is it okay for me to click? Are you guys okay? We're good? Okay, awesome. So let's keep going. We're going to now graph, and I wish I would have taken that off. I don't mean to do that. We're going to now graph f of x is equal to -4. And we're going to come up with the domain and range. Now we just learned this, and I know it's only been like a few minutes and it takes time to process, but show me with your arms if you know what this graph looks like, if you remember. Okay, so I saw this, and I saw this, and I think I saw a thumbs up, which is kind of funny. So this f of x is fancy for y equals -4. So if it's a y equals and there is no x, the degree is 0 and it's a constant function, it's going to be a horizontal line. So we're going to have a horizontal line at y equals -4. So at -4, I can just draw that horizontal line. But what's really cool is the table. And the table, there is no work for this. I will just have X and Y. And what ends up happening is really cool. My Y value has to be -4 the whole time. I mean, it says it right here, right? It says that Y is equal to -4. My X value can be anything. It could be -2, -1, 100, 1,000. It doesn't matter what my X values are. The entire time, my Y values are -4. And even if I plot these ordered pairs, -2, -4 would be right here on my graph. -1, -4 would be right here. And then I went a little crazy, but 100, -4, and 1,000, -4 would be like way over here, right? Which is on my graph. So my domain is still left to right. It's a part of my function from left to right. So my domain is still -infinity to +infinity. But my range is very limited because my range is just my Y values, which in this case is -4. So this would be the set of -4. All right, so now we're going to do a challenge, and then it gets a little bit better, and then we're going to try to start graphing. And we might not graphing quadratics. We might not finish quadratics, but we can at least get started on them. And if we finish them, that will be an extra great thing. It'll make it better for the other days. Okay, so let's go ahead and move into a more difficult question, which is example 4, 3x plus 4y is equal to 12. We're also going to be giving the domain and range, but we're mainly trying to graph this. We're going to make a table like we've been doing. And this time, the function is written differently. It's 3x plus 4y equals 12. It's not y equals blah, 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 or f of x equals whatever. It is written differently, and that's okay. It's still a linear function because my degree is still a 1. And we can still make our table to help us. There is a little trick that I want to show you that is mathematically sound that will also help us. Okay, so first thing I want to do is pick a value for x. I'm always going to pick 0 first. I cannot help it. It just is efficient and easy. And it also gives me the y-intercept, which is cool. So when I plug 0 in for x, this is actually going to require like a little bit of special skills here because I'm going to have to solve for y. So when I plug 0 in for x, this piece right here becomes a 0, right? 3 times 0 is just 0. And then I have 4y equals 12. And that's 4 times y equals 12. So I would divide both sides by 4 to get y equals 3. So when it looks like this format, I have to do a little bit of algebra, but the algebra is not that bad. All I had to do is divide both sides by 4. So 0, 3 is my y-intercept. It's one of my ordered pairs. And then to find another ordered pair, I'm going to have you do something a little different. Now you could, hypothetically, you guys could pick values for x. Maybe you pick 1 or 2 or 3 for x and you solve for y. But actually, there's a really smart, clever trick, which is to plug 0 in for y and solve for x. Okay, so I know that all this time we've been plugging in for x and we've been picking x values, but I want you to know you can also pick y values as well and solve for x. So that's the little like disclaimer thing that I would do. I would go ahead and plug 0 in for y. So 0 is going to go in for y, which is right here. And so I'm going to have 3x plus 4 times 0 is equal to 12. And this solving is really not that bad because I have 4 times 0, which of course is just 0. Like that's really why I like to use 0, because that goes away. And what I'm left with is 3x is equal to 12. But it's not really 3x, it's 3 times x. So to get rid of that 3, I would just divide both sides by 3. And I get x equals 4. And now I have my x value. So my ordered pair would be 4, 0. And that is also the x-intercept. That's where it crosses the x-axis. This is the y-intercept. That's the x-intercept. So when you do that trick, you're actually also finding another important piece of our graph. So 4, 0 would be right here. And then this is what my graph would look like. Are there any questions on that one? That was a little tricky, but for this section, that's as tricky as it gets, really. Besides the constant and vertical graphs, which we're gonna summarize that, and then we'll move on to quadratics. Are there any questions before we move into the next part? And please feel free to stay on if you are not wanting to ask the question, because I know that I've been in that position where I just don't want to ask, and so you can wait till later. All right, is it okay if I move? Thumbs up? You guys are good? Okay, awesome. All right, so one more wrap up here with x equals 5 and y equals 5 in our domain and range, and the differences, because people really get this confused. So x equals 5 versus y equals 5. When you have x equals 5, and also I want to point out that y can also be written as f of x. So also known as f of x. So it could be written either way, right? When you have x equals 5, show me with your arm, what does that look like if it's x equals? Good, it's vertical. Yes. Okay, what about y equals? Horizontal. Awesome. Okay, so x equals 5 is a vertical line. This is a horizontal line. Ooh, I can spell horizontal line. So vertical, horizontal. The domain for our vertical lines, our domain is just the value itself. Whereas if it's horizontal, our domain is still negative infinity to positive infinity. For my range, this is negative infinity to positive infinity because it points all the way down and it goes all the way up. But for my range over here, we're very limited. In this case, it would just be 5. Those are the differences between the vertical and the horizontal. And sadly, this is not a function. We still have to know it, but it's not a function. This is a function. This does pass that vertical line test. Like if I put the vertical line across it, we're good. All right. You guys are doing great. Hang in there. We are going to move into quadratics in just a second. Okay, so we're now going to talk about graphing quadratics, and I just cannot help but use a soccer reference. So if any of you have played soccer, and I know some of you have, you think about the path of a soccer ball that actually can be modeled by a parabola or a negative quadratic function. So when you kick a soccer ball, shoot an arrow, fire a missile, throw a stone, it arcs up into the air and then it comes down. And that follows the path of a parabola. So we're going to talk about what a quadratic function is. So we're switching to the next little section. So we just did linear functions. Now we're going to talk about quadratic functions. Quadratic functions are different. They have a curve. So the definition of a quadratic function is it's a polynomial, which you're going to learn more about very soon, I promise. It's a polynomial function of a second degree. And let me explain what that actually looks like. So I'm going to give you an example of a quadratic and what is not a quadratic. Okay, so one example of a quadratic would be f of x equals x squared plus 4. The reason why that's considered a quadratic is because that degree is a 2. What would not be quadratic would be, would be f of x is equal to 2x minus 1, because the degree on that is a 1, which would make it, of course, linear, right? Which we just learned. All right. Now, another quadratic example would be 2x squared minus 5x minus 2. The reason why that's quadratic is because the highest degree is a 2. So the highest degree basically prevails as like the one we look at, because this also has a degree, or the 5x has a degree of 1 itself, but the higher degree is the one that wins. So an example of what is not quadratic would be like x cubed minus 2x squared plus 5x plus 4. And the reason why that would not be quadratic is because the highest degree is 3. All right, let's do one more. So another example of a quadratic would be negative 4/5 x squared. The reason why that's considered a quadratic is because of the squared, or the 2. So if it's squared, it's a quadratic, but if it has a higher degree, then it would not be quadratic. And then another example would be the square root of x, which we learn about soon. Okay, so that's the differences between quadratic and not a quadratic. We're going to graph this in just a moment. So what I'll have you do is give me a thumbs up when you're ready to move, because I see some of you are writing. Okay, I think we're good. Awesome. All right, so we're going to graph quadratic functions. So once again, we're going to create a table and we're going to plot some ordered pairs. And this is the most basic quadratic function. It's just f of x is equal to x squared. And a lot of times we call that like our parent function. It's just our basic quadratic. So we're going to have f of x is equal to x squared, and then our y coordinate and x comma y. Okay, but this time, so we can kind of get the full view of the graph, we're gonna do a little bit more. We're gonna do -2, -1, 0, 1, and 2. Okay, so we're actually gonna do more ordered pairs so we can see what that shape looks like. So when I plug -2 in for x, which I'll do this in red, that would just be, so f at -2 is equal to -2 squared, which is 4. So when I plug -2 in for x squared, I do -2 squared. Now, if you type -2 squared into your calculator, it will tell you -4. But we know that -2 squared is -2 times -2, which makes it a positive 4. So if you type it into your calculator, I would caution that you use parentheses around the number, and then you'll be fine if you're using a calculator. So this would be -2, 4. And then when I plug -1 in, I'm going to have f at -1 which is just negative 1 squared. Well, negative 1 squared is negative 1 times negative 1, which is definitely a positive 1, right? Two negatives make a positive, so that would be a 1. So negative 1, 1. And then when I plug 0 in, I do 0 squared, which is just 0. And then I'm going to keep going. I'm going to plug 1 in. 1 squared is 1. I'm going to plug 2 in. 2 squared is 4. And at some point on your table, you know, if you're tired of writing it all out, you can do kind of like what I just did, right? So I kind of abbreviated a little bit instead of putting that f at 0. But all we're doing is plugging the values in. So that's 4. Whoops, did not mean to write it in shade. Let me try that again. Okay, so this is 4. So then I have 1, 1, and 2, 4. Okay, now we're going to plot this and see what this looks like. So at negative 2, 4, I will have an ordered pair. And then at negative 1, 1, and then 0, 0, 1, 1, 2, 4. And I'm going to go ahead and connect these. And what happens is it kind of makes like a U shape. So we call this a parabola. My husband calls it a parabola, but it's actually called a parabola. But it's okay if you say it wrong. It's not a big deal. So it's a parabola. And we can come up with the domain and range based on this. Kind of like with what we already know, we can definitely do the domain and range. So my domain is negative infinity to infinity. And the good news for you, actually, is that when it comes to the domain of all quadratics have a domain of negative infinity to infinity. So every quadratic that exists, its domain is negative infinity to positive infinity, no matter what. So that's kind of nice. The range, however, you can think about this, and I bet you can tell the range is going to be unique to the quadratic itself, right? Because if you look at it, when I think about the range, I'm going from bottom to top. So way down here, I don't have a graph. My graph doesn't start until 0, right? So from 0, and then I've got these arrows going up. So from 0 to infinity would be my range. And I include 0 because 0 is an ordered pair on my graph. So I'm going to use a bracket there, and my infinity looks whack. So let me fix this infinity. I'm sorry about that. Okay, so from 0 to infinity. All right, now let's talk about when is it increasing and when is it decreasing? Well, if you imagine if you're on the graph, it's going to be decreasing from left to right. It's going to be decreasing from negative infinity to 0. So it's decreasing from negative infinity to 0, and it's increasing from 0 to infinity. So that would be 0 to infinity. This shape is typical of positive quadratics. But I do want to kind of scroll down a little bit to talk briefly about negative quadratics. So negative quadratics would be if I had negative x squared. So we just did positive x squared, right? We did a positive x squared right here. But if I have a negative x squared, what it does is it takes this graph and it flips it over, so it kind of looks like that. So I just want to kind of sketch that for you, that it would just take it would take this graph up here, if you can imagine just taking that and flipping it over the x-axis, it would look like that. So that's what a negative quadratic looks like. So we've got a positive quadratic, we can have a negative quadratic. Well, there are some special properties of quadratics. As you can see by the graph, there's quite a bit going on there. So, is it okay for me to click? You guys are good? Good? Okay, so let's talk about some important attributes of quadratics. So the first thing I want to talk about is the vertex form of a quadratic. And that can be written as f of x is equal to a and then parentheses x minus h squared plus k. So sometimes our quadratics are behaving really nicely and they're written in this form that we call vertex form. And when this happens, it's really nice because it actually gives us the coordinates of our vertex. Now, if you think about the vertex is the place on the graph where we go from increasing to decreasing. So on my little U-shaped parabola on the last problem, my vertex would have been at 0, 0. But we can move the graph around. And so my vertex would be at h, comma, k. So I can look at the quadratic itself to figure out what the vertex is. Now, this is extremely useful because sometimes having to create a table of values all the time takes up a lot of time. But also, if it's already in vertex form, it's just a lot faster to graph. Now, the axis of symmetry is just x equals h. And I'm going to show you what this means with our example. Okay, so for our example, we have the quantity of x minus 3 squared plus 5. We are going to find the vertex based on that. And all we have to do is take this value, and you can see that it's a minus here, but it ends up being a positive. So that means my vertex will be at 3, and then my y coordinate would be at 5. Now on Thursday, we talk about transformations, and that'll like all come together for you. So at 3, 5, I'm going to plot my ordered pair. And I'm going to just kind of sketch that U shape. And now I want to label this for you. So this is my vertex. It's the point at which I go from increasing to decreasing. And then my axis of symmetry is x equals 3. Now the reason why it's x equals is because the axis of symmetry is a vertical line that cuts the graph perfectly in half. So if you think about this vertical line on my graph, I can cut it perfectly in half at x equals 3. In fact, I'm going to show you what that looks like in green. So x equals 3, if I draw this on my graph, you can see that that cuts my graph in half. And that quadratic could be like folded on top of itself. So the axis of symmetry is the vertical line that cuts your parabola in half. We call it the vertical line of symmetry. Okay, now I'm going to move this up just a little bit. I'm going to have a little temperature check to see how you guys are doing. I'm going to add in an extra one. Okay, so I'm going to ask you to find the vertex and axis of symmetry of f of x equals that one. Okay, so I'll give you a moment to try it. You can type it into the chat. Nice work. Several of you have sent me direct messages, and you are correct, those of you that Well, actually, some of you are close, okay, because now I see a whole bunch. So the key is this sign changes. So if it's a positive in here, it's actually going to make it go to the left 6, which is -6. And it's not letting me write. No, hold on. We change that sign, we get -6, and then the other sign does not change because that would just move my graph down -7. And when we do transformations, it's really going to help a lot. And then my axis, so this is my vertex, and then my axis of symmetry is always the x coordinate of my vertex. So that would just be x equals -6. So if I wanted to sketch this really quick, I would be over to the left, and then I would be down 7. And so it would look something like this. And then my axis of symmetry would be x equals -6. Okay, I think you guys are okay. Like I said, I know this is a lot, and I apologize. But condensing a 16-week course into 5 weeks is crazy. We're gonna get through it, I promise, and I will help you. Stay on if you're lost. I can go back and help you for sure. Okay, we're going to go ahead and move into what happens when the quadratic is not in vertex form. So I want to show you what that looks like. Is it okay for me to click? You guys are good? Okay. So when the quadratic is not in vertex form, that would imply that it is in standard form. Okay, so I'm going to give you the vertex formula. And so when you guys take your test in this class or even your final exam, you get to have a sheet of paper and you can write whatever you want on that paper to help you. So like this would be a formula that you would want to have on that paper because it will help you to find the vertex. So it's just one of those formulas that we're going to be using in this class. It's called the vertex formula. If the quadratic is not in vertex form, we would use this formula. And that would mean that our quadratic is probably in standard form, which looks like that. So ax squared plus bx plus c is what we call standard form of a quadratic. And so the formula itself, we're getting from our coefficients of our quadratic. And we're going to do some examples that will help us. So the vertex would be, and hold on, let me give you the actual equation. So if I had f of x equals x squared minus 4x plus 2. All right, we're going to do this one first. I don't know why it didn't come up on the screen, but this is the problem that we're going to find. We're going to find the vertex for this. Now, one thing you could do if you were desperate is you could create a table of values, maybe from like -10 to +10, and just keep plugging the numbers in and then plot all the points. And like eventually you would see the vertex, right? But we want to take that guesswork out. We actually want to use the formula itself. So for this expression, I'm going to find the vertex by using my formula. So in this case, A would be 1 and B is -4. Now, how I got those numbers is because A is always the number in front of x squared, right? And B is always the number in front of x. So those are the letters I'm going to use. And then I'm going to use my formula. So I'm going to do this down here because I'm running out of space. I'm going to use my formula to do this. So I'm going to take the fact that A is equal to 1 and B is equal to -4, and I'm going to plug that into -b over 2a. Okay, so B is -4, so when I plug that in, I get -4, and then over 2 times a, which is 1. Well, then I work that out. So a negative 4, of course, is just a positive 4. So 4 over 2 is just 2. Now what I just found is the x-coordinate of my vertex. So I just found the x-coordinate of my vertex. To find the y-coordinate, what this means right here is to take whatever you got and to plug it in for x, and that's going to give you y. So to find the y-coordinate of my vertex, I'm going to take the x-coordinate that I just found, which is 2, and I'm going to plug that in to my function itself. So right here, I'm going to be plugging 2 in for x. Right, so I'll show my work for that. So I'm going to have 2 squared minus 4 times 2 plus 2. And at this point, you can use your calculator if you want to type that in, or you can do it by hand. So that would be kind of like up to you how you would want to do that. So I would have 2 squared, which is 4, and then minus 8 plus 2, which would be negative 4 plus 2, which is negative 2. So that is the x-coordinate of my vertex. So my vertex is 2, negative 2. So I do the negative b over 2a. That gives me the x value. I take that x value, I plug it back in to the function to find the y value. So at 2, negative 2 would be the ordered pair for my vertex. And then as far as it goes for my labs, I would want to come up with one more ordered pair. So I would choose any value. So choose any value for x to get that last coordinate, right? So you could even make a small table if you wanted. Like I would have x and then x squared minus 4x plus 2, and then the y, and then x comma y. And so I might choose 0 for x, because 0 is always like a fun thing to pick. Because when I plug in 0, I just get 0 squared minus 4 times 0 plus 2, which when I plug in 0, like this goes to 0 and this goes to 0, and I'm just left with a 2. So 0, 2 would be my other ordered pair. And that's all you're going to need for my labs. You would click on instead of clicking on the line, you'll click on this, and I'll post that video as well. And then you just click on the both ordered pairs. But it is symmetric, so I would also have an ordered pair there just based on symmetry. I could use that to help. So here's what that graph would look like. And then of course my axis of symmetry would just be x equals 2. Which if you think, if I'll do this in yellow, that does cut my graph perfectly in half. Well, I know that this is difficult. This is a difficult subject. And so what I want to do is I want to do a few more of these difficult problems to make sure that you guys are a little more comfortable with it. Because that's as difficult as it gets really for the quadratics. Of course, we still have to do the increasing and decreasing and domain and range as well. Okay, so let's try a few more. I think that will help you practice, because I know this is like a lot of information. Okay, so we're going to try this advanced example number 2, and then we're going to go really crazy after this with an even crazier example. So I want to give you a moment to at least try to use the vertex formula. Remember, the vertex is negative b over 2a. And then we just take that value and plug it in to get our y value. Okay, so I want to give you a chance to at least find the vertex. Feel free to type it into the chat if you find it fast, because that will help people. But we'll go over it in a few minutes. I'll give you a few minutes to try it. So let's get back together and see what's going on. So first thing we want to do is we want to figure out what is A, because that's going to help, and what is B. Okay, so remember, a is just the number in front of x squared. In this case, it's a 1. B is just the number in front of x. In this case, it's a 2. So I would want to declare that because that's definitely like a crucial thing to know. And then I'm going to plug my 2 in here, and I'm going to plug my 1 in there, right? And all I'm doing is plugging that in. But I got to be careful. I don't want to make a mistake. It's easy to make a mistake. So I'm going to have negative 2. Now the negative I'm getting right here from the actual formula itself over 2 times A. So the B was 2, it went right here, and then the A was 1. And so that becomes oh, I was looking at the wrong one. Okay, sorry. That becomes negative 1. Okay, good. So if you have negative 1, that was right. Negative 2 is wrong. Okay, so we have negative 1 for our x coordinate. Now, how many of you got negative 1? Good. Okay, I know some of you did because you told me you did. All right, so now I'm going to, oh yeah, go ahead. Cyril, do you have a question? You can unmute. Oh, okay. All right, that's cool. I was just making sure. Okay, so now I'm going to take negative 1, and to figure out my y-coordinate, see, we're halfway done with our vertex, right? We got to find the y-coordinate. So to find the y-coordinate, all you have to do is take your x-coordinate. So take x equals negative 1 and plug it in to our function. And that makes sense because if our x-coordinate is negative 1, to find our y-coordinate, we just plug in negative 1 for x. That will always give us our y-coordinate. But when I plug in negative 1, I have to be very careful, right? I want to hug it in parentheses, perhaps use a calculator if I need to, but I want to be very careful here. So I plug negative 1 in, and I end up with negative 1 squared, which is positive 1, and then plus 2 times negative 1, which is negative 2, and then minus 5. So I have 1 plus negative 2 minus 5, which ends up being negative 6. And I would totally use my calculator to check that because it's really easy to make a computation mistake. Now I know that some of you had that completely correct. You sent me a message, so that's cool. Okay, so now I'm going to plot my vertex. So negative 1, negative 6 is down here. And then my axis of symmetry is x equals negative 1. And I would totally do one more ordered pair to help me. Okay, so what I'm going to do is for my extra ordered pair, which MyLabs is probably going to require, for my extra ordered pair, I would just plug 0 in, right? I'm going to plug 0 in, and that will give me what I need for my ordered pair. So when I plug 0 in to my function, I can do that really fast because it's a 0, right? 0 squared is 0. 2 times 0 is 0. So it's not a surprise that I end up with negative 5, right? So I can plug 0 in. That's just a real efficient value to always use. So 0, negative 5 would be my other ordered pair. It is symmetric, so if I wanted to be fancy, I could actually go ahead and plot that other ordered pair on the other side of it because it is symmetric graph. So then it would look like this. And of course, my axis of symmetry is x equals negative 1. And then this really falls back on what we learned yesterday, right? So my domain is negative infinity to positive infinity, which it always is for a quadratic anyways. So always. My range is from the bottom to the top, so that's going to be negative 6 to infinity. And I can see that it's -6 because that's my y coordinate of my vertex, right? That makes sense. And then I'm increasing from -1 to infinity. And that is represented here, -1 to infinity. And I'm decreasing from -infinity to -1. I know that this takes time to process, especially because this part we did yesterday. So, and I know it's probably difficult to like try to do the homework in a timely manner because you guys are really busy and you might have more time over the weekend and things like that. But remember, all of our due dates are soft due dates. So if you turn something in late, it's not going to take off. We just have to have that in place. Okay, we're going to go a little crazy with this next example, but I'm really excited for it. It's really going to push you, but that's a good thing. And that's the last example, and we'll have a quick exit, and then you can stay on and ask questions if you need help, okay? So move on to the hardest, most difficult question on this topic, which is also one of your homework questions. I try to make it very similar to help you. So the reason why this is more difficult is because we have a -4 in front of x squared. So our a is going to be, special. It's going to be -4 instead of 1. Also, the quadratic itself is negative. So when we graph it, we don't want to graph it like this. We want it to be face down because it's a negative. All right, that makes it a little tricky. Okay, so this is a very difficult question. And I know it's only day 2 and I feel really bad, but we're going to do it. So I want to give you a chance to at least try it. I'll give you a few minutes and then of course we'll go over it. So if you get the vertex, please type it into the chat. And listen, type it in for everybody to see because it actually helps with like for conversations and things like that. So please type it into the chat when you get it. I'll give you a few minutes. Start on it and they are good answers. So that's great. All right, so I'm going to go ahead and label the fact that A is equal to -4 and B is equal to -48. And remember, A is just the number in front of x squared and B is the number in front of x. That will actually help us when we do the quadratic formula, which is soon. And then I'm going to use that formula, -b over 2a, and then of course this f at -b over 2a just means to plug that, whatever value you get in for x, just find the x coordinate and the y coordinate. Okay, so here's b. I'm about to plug it in there. And here is a. It's about to go right there, right? I'm just plugging these values in so that it's not too bad, but I want to make sure I don't make a mistake. Okay, so I'm going to have -b over 2 times a. So that's what it looks like just plugging the numbers in. I'm going to have this -48, which I know becomes a +48. So I'm going to go ahead and write that as a +48. And then I have 2 times -4, which is -8. And then when I divide that, I end up with -6. That represents the x coordinate of my vertex. And in some cases, I'll be honest, if it's a multiple choice test, you might be finished because it might be the only answer choice that has the x coordinate correct, which is kind of cool when that happens. But we want to go ahead and finish the problem. So I'm going to take -6 and I'm going to plug -6 in to my original function where my x's are at. I'll do this in blue. So I'm going to have -4 times -6 squared minus 48 times -6 minus 128. So all I'm doing is taking the -6 that I got and plugging it in for x. And I'll be honest, with these numbers, personally, this would turn to my calculator. Like I wouldn't even try to do that by hand. I would just go straight to my calculator. Just so I don't make a little mistake. It's really easy to make a little mistake. And I would put parentheses around that -6. Now, if you do that part correctly, the result is 16. So you might try typing that in to your calculator. If you don't have a calculator, remember the Desmos Scientific Calculator is a great free calculator that you could use. Now my axis of symmetry is just x equals -6. It's always just my x coordinate. And it's always x equals because it's always a vertical line. Now I'm going to plot my vertex. So at -6 and, oh wow, 16, I'm going to be like way up here, right? This is kind of hilarious. I don't think I meant to make one that was off the screen, but that's okay. It would be over there somewhere, right, up to 16. But I do want to point out, since it's a negative quadratic, it is going to take it and it's going to flip it. So it's going to be facing down like this, just FYI, because it's a negative. Now my domain is always the set of all real numbers for quadratics, always going to be -infinity to +infinity. My range, however, I will have to take a look at, right? And if you think about it, ranges from bottom to top. So way down low, way down on the y-axis, here's -infinity. This arrow does approach, I mean, it gets to -infinity. So -infinity is part of my range all the way to the highest value on my graph, which in this case is 16. So when it comes to my vertex, the vertex y coordinate will always help me with my range. I'll use that value in my range. Now for increasing and decreasing, and I know this is a lot and you have to like switch gears. Now we're going to talk about increasing and decreasing. Now I want you to imagine you're on the graph. I'll do this in purple shade. So I'm on the graph, I'm right here. I would be increasing. I'm increasing, I'm increasing, I'm increasing. Oh, now I'm not increasing. That value for x is -6, right? So I am increasing from -infinity because of the arrow. I'm increasing until I get to -6. And we always use our x values to describe those intervals of increasing and decreasing. So I'm increasing from -infinity to -6. Then I get there and I start to decrease. Well, I start decreasing at -6 all the way to infinity. So this will be -6 to infinity. I know this is like information overload, but the good news is our first test is not until next week, which is great. So you're going to have the weekend to hopefully like process some of this information because I know it's a lot. Okay, so we're going to do an exit. And once you type your answer into me, you'll be free to go. But you can stay on if you need help or if you have questions. And I know at least one person who had emailed me previously will stay on, and I'm going to help her with that question. But other people can stay on as well, okay? So let me go to our exit. And then I'll be posting this video later. I'm going to try to do it tonight. Okay, so here is our... I'm going to switch gears. I'm going to have you guys find the vertex of that one, and we'll do this one. Okay, all you're doing is finding the vertex and axis of symmetry. You don't have to find anything else. And you can text me. You can private message me your answer. And then you're free to go. And then, like I said, please stay on if you need help.